Hey there. I've been noodling around with Vulkan for the past 6-ish weeks, and I'm have a cool little demo to show here. It's literally 1 in the morning. I just got this working to a really cool standard, and I wanted to show it off. This is 200,000 cubes being rendered with motion. I can do a lot more complex motion without any more cost to this, but yeah, 200,000 cubes. Um, each one is each face on each cube is shaded based on its angle to the sun. I can texture map these without I can change like 3 lines of code now. I can texture map each of these cubes. I'm not going to because that would kill this performance. Each cube is loaded from an OBJ model. I wrote my own OBJ model loader, which is capable of loading with correct face normals and UV coordinates. This demo I'm showing right now is kind of a recreation and inspired by a demo that a friend of mine created a while back, playing with Unity ECS, and I'm like, I can do better than that. My hardware is significantly crappier, and I'm doing double the number of cubes that they were, which is fun. I'm sure they could turn it up, but when I'm not recording, I can get up to about 400,000 cubes before things start noticeably stuttering. Around 500,000 cubes, you can tell it's starting to dip down to the low 40s in terms of frame rate. I'm not measuring frame times yet. I really should be. I keep putting it off because it's kind of, why do that when you can do fun stuff like this? The motion of each of these cubes is not controlled by any sort of, it's not controlled by the CPU directly. Technically I could without changing too much stuff, because I'm technically sending a whole three component vector for every single cube to the GPU every single frame, which is wasteful in this specific instance because all of the movement calculations being done in the vertex shader here. I'm looping time, and then it's just an easing function on the vertex shader that's moving from the origin to a target position. That's those vec3s I was just mentioned, over time, and it loops time. So technically only the time has to change, has to be modified by the CPU, but I am sending those target locations every single time because that was easier. And if I wanted to do anything complex with, like, if these wanted to be entities that were controlled by the CPU, I'd have to upload that data anyway, so it's not a big deal. You can pump an impressively large amount of data to a GPU each frame without that being a bottleneck. It's amazing. This is running on a really crappy graphics card. This is a R7 360, which is a crappy low-end graphics card from 2015. Barely new enough to have Vulkan support. Yeah. I want to show this off because I'm really excited about this. I have a bunch of really cool plans to show off. We can look at the code a little bit. This project is fairly small. Like, if I were to come in here and if I do a naive line count, it's 3,300 lines ish. But a more robust count would be like 2,700. So it's pretty small, really quite small. I was told before getting into like all the stuff you hear is like, oh my goodness, Vulkan's so hard and complicated, and it is in some areas, but like everything it asked me to do to like get anywhere made sense that I had to do it. So I guess not having any prior experience with any sort of actual graphics APIs helped me in a way. I don't know. I just did a big refactoring and moved stuff into all sorts of stuff. We can look at the vertex shader first. Interesting quirk with Vulkan is that the vector 3s have the same size and alignment as a vector 4. for some reason with Vulkan. I don't know if that's true for OpenGL, but it is for Vulkan. It's like it's in the Vulkan specification. So even if like you're compiling out of SpirV, like that, vector 3 is for 4 floats wide. So I'm in my UBO. I have, this is a holdover. Like this is anyway. I have my view and projection matrices, and I have my time, and then I have this big ass array of vector 3s, and this was originally vec 4 to get around the issue, because when I was just uploading vec 3s, because on the Rust side, the vec 3 is the size of 3 floats as opposed to 4 floats. It had the wrong stride when it was uploaded to the GPU, and just like nastiness occurred. But by creating my own 3 float structure, I can do that, and then I can just like destructure it into an actual vec 3 in the vertex shader that I can then work on. And that's pretty much the fanciness here. Is just like each vertex looks up its target location by which instance of the cube it is, and that's being done from over here. I'm doing instanced rendering, which means that as opposed to uploading 200,000 copies of the cube, you upload it once, and then you tell the graphics card, hey, render 200,000 copies of this, please. And then the vertex shader can like say, oh, I am instance such and such, and then look up its target. Yeah, so this is a big ass array of vec 3s, which was a bit of a problem because this is pretty big. If we were to actually calculate that right now, 4 times 3, so 12 bytes per each, and then so it's that many bytes in total, that many kilobytes, 2.2 megabytes for 200,000 cubes for their target location that's being uploaded to the, which is almost 2.3, that's being uploaded to the GPU every single frame, which is like trivial in terms of like the bandwidth that bus can handle. But that does mean that this stack overflows. So I'm doing some nasty stuff where I'm like, oh god, this is really nasty. I have enough space to construct it once, so I construct it on the stack, and then I copy it to the heap, because Rust has some weird semantics with allocation. It's one area I'm not quite fond of. I love this language. I've been writing Rust primarily as my primary language for almost 2 years now. I'm not very fond of blocks. I'm just going to say I'm not very fond of blocks. Doing manual allocation in Rust is a bit of a pain. Anyway, so, and I do it up here in a minute, and we're going to talk about that. So I construct the targets once, and then I box it onto the heap, so now it's no longer on the stack. But then, so at that point, it seemed logical that like, oh, I can create another copy of it on the stack, because this copy no longer exists on the stack. I can create another copy on the stack for the current UBO, and then that's fine, because there should be enough space. But no, actually there wasn't. So every time I create a UBO to send to the GPU, I have to box it as well, but there's not enough space to construct on the stack before putting onto the heap. So I allocate a completely garbage copy on the heap, and then I populate it manually, which is utterly nasty, and then I return a box from that. Horribly nasty, but it works. And then the rendering can just, because it's just it gets passed in here as a reference, it just like can dereference into the other, and it just copies over. This is where it gets copied into GPU memory. This right here. So there's a lot of other stuff here, but I realize that that's not interesting. yeah, I'm really excited about all the things I can do with this. Um, yeah, that's it, I guess. Cheers. See you around.